Welcome to the chapter 5.4 lesson video. Today we're going to be talking about the sine and tangent sum and difference identities. So we already learned about the cosine sum and different identities. There are identities for sine and tangent as well. These are just other identities that we need to memorize. So we'll show them first. When I put that slide up, I really encourage you, make sure you write them down somewhere where you can quickly reference them in the future or look back at them. They're also in your book if you ever want to look back there. But this would be a really good idea to have out in front of you as you're doing your work and your assignments to really help you out. Memorizing them is pretty important. If you can take the time to do that, it'll save you a lot of time as well. All right, so we're going to talk about sine sum and difference and tangent sum and tangent sum and difference identities, and how to use them to evaluate and different types of problems that we can do with them and that you'll see. And then if there's time, we'll talk about some verifying identities with sine and tangent sum and different identities. All right, so here is the sine, sum, and difference identities. It's a little bit different looking than the cosine one, and you'll notice that right away. So the cosine one of the big things was whatever sine is on the inside, it was the opposite when you expanded it. So if it was positive, then it was negative. If it was negative, it was positive. This one, they match. So sine something plus something is still plus over here. Sine something minus something is still minus over here. Otherwise, it follows a really similar pattern to the cosine one, but again, there's a couple differences. It's the sine of the first, cosine of the second, plus sine, cosine of the first, sine of the second. So you'll notice it goes sine first, cosine second, and then it switches the order. Cosine first, sine of the second. And the sign matches once again. The subtraction one is the exact same stuff, except it's a minus. So it's sine first, cosine second, minus cosine first, sine second. So that is the key difference here. It should look fairly similar to the cosine ones, except you'll notice this time they don't match here. They do one of each, and then the sine matches what was on the inside. Okay, so let's try a couple. We'll just kind of evaluate these and see what happens. So the first one we have is sine of 30 plus theta. So we'll go ahead and we'll rewrite that. It's going to become the sine of 30 degrees cosine of theta plus the cosine of 30 degrees times the sine of theta. All right, we'll evaluate the pieces that we do know the answer to, leave the pieces that we don't know the answer to alone, and then see if there's anything else we can simplify. So we have sine of 30, that is 1/2 times cosine theta, plus cosine 30 times sine of theta, that is root 3 over 2 times sine of theta. All right, so we'll go ahead and do that multiplication, and they have a common denominator. So we end up with cosine of theta plus root 3 sine of theta over 2 as the common denominator. And that's our answer. That's all we can really do here. We evaluated, we simplified, and that's good. Now, that was with one of them being a theta. Now this next one over here, this one is a little bit different because not one of them is a theta. So we're going to go ahead and we'll rewrite this as what we're going to use it as. So we're going to rewrite this as sine of, you can kind of pick and choose whatever you want. I want to do sine of 60 minus 45 for no particular reason. That's just the one I chose. You could have done 45 minus 30. You could have kind of done it a couple different ways. So that's just the one I chose, so that's the one we're going to use. So you'll rewrite that as the sine of 60, the cosine of 45, minus the cosine of 60 and the sine of 45. All right, you'll evaluate each of those pieces. Sine of 60, that's root 3 over 2. Cosine of 45, that's root 2 over 2, minus cosine of 60 is 1/2 times, there's multiplication there as well, times sine of 45 is root 2 over 2. And you'll notice these are really similar to answer to what the cosine of 15 is, but you end up with root 6 minus root 2 all over 4, because 2 times 2 is 4. Box your answer. That's what we're looking for. One other problem you might see is going back the opposite direction. contracting it down. So this, for example, it says the sine of 40, I don't know how to evaluate that. Cosine of 160, I don't know how to evaluate that. Minus cosine of 40, sine of 60. None of those are ones we know how to do by hand or have memorized. So what we can do is we can try and contract it back down. So the way the pattern works is if it's sine something, cosine something minus cosine something, sine something, it contracts down to be the first thing minus the second thing. Remember, because it matches the sign. So we're going to contract this down, and we're going to change it to be the sine of the first thing, 40, minus the second thing, 160. Well, let's see what that is. 40 minus 60, this is going to be the sine of negative 120 degrees. Hey, that is a decent reference angle. We'll add 360 to it, so it'll change to sine of 240 degrees, just to get it back to a 0 to 360 degree angle. 240 degrees is somewhere in quadrant 3. It is a 60 degree reference angle, which means my opposite side is root 3, but negative. My hypotenuse is 2. So the sine of 240 degrees, this piece right here is going to equal negative root 3 over 2, final answer. So we couldn't evaluate it back in this form, but when we contracted it back down to the sine difference identity, we could then subtract it, get the sine of negative 120, which we could find a reference angle for and evaluate to get that answer. So this top thing up here is equal to negative root 3 over 2. All right, the tangent sum and difference identity looks a little more complicated. Luckily, it follows kind of the same thing where there isn't, the sum and difference ones are fairly similar. There's just some differences in the plus and the minuses. So the tangent of A plus B is the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. Or down here, this is the tangent of A minus B is the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. So a couple things to notice. The top sign matches, so plus, minus, right? It matches. The bottom sign is opposite, plus to minus, minus to plus. Otherwise, they kind of have the same pattern. It's the first thing, the second thing over 1, and then the first thing and the second thing being multiplied. Otherwise, you can kind of figure out the signs based on what the original sign is here. All right, so let's give this problem a try. All right, so I have 2 of them here, and really it comes down to a couple of them. The second problem's a little more work, and we'll talk about it. You're going to see something just like this on the test, and so I really want to emphasize this, and we'll practice it a couple more times, especially in class. But we'll try this first one, this top one first, the tangent of 105. So I get to pick how I want to rewrite that. I'll pick tangent of 60 plus 45. No particular reason. Those are just the 2 angles that first came to mind when they add up to 105. So I'll rewrite that as the identity, the tangent 60 plus tangent 45 over 1 minus tangent 60 times tangent 45. Now, the one thing I have to warn you is there is a little bit of simplification involved in these problems. So you got to kind of take your time and be patient with it. I'm going to move up a little bit so I have some more room to work with. So I'm going to move it up here. So first things first, let's evaluate each of these. Tangent of 60 degrees is root 3. Tangent of 45 degrees is 1 over 1 minus tangent of 60, we already found was root 3. 45 is 1. Root 3 times 1 is root 3. Now, this looks like a fairly simplified answer. However, there is one catch. We cannot have radicals on bottom, so we do have to rationalize here. So I'm going to multiply the top and bottom here by 1 plus root 3 to get rid of that radical. That's something we learned earlier on in our math careers, 1 plus root 3. And I'm going to go ahead and FOIL these out. So on top, I have root 3 times 1 is root 3. Root 3 times root 3 is 3. 1 times 1 is 1. And 1 times root 3 is another root 3. On bottom, I have 1 times 1 is 1. 1 times root 3 is root 3. Negative root 3 times 1 is negative root 3. That's nice. And then negative root 3 times root 3 is negative 3. So these two pieces cancel. And then let's combine our like terms. We get 4 plus 2 root 3s over 1 minus 3 is negative 2. So what we end up with looks like it could be a final answer, but there is just a tiny bit more simplifying to do. If you look and see, all of the coefficients, the 4, the 2, and the negative 2 are all divisible by 2. So we'll divide those all by 2, and then we'll almost be there. 4 divided by 2 is 2. 2 root 3 divided by 2 is root 3. Negative 2 divided by 2 is negative 1. The last thing you can kind of do, and this is pretty close to right answer, the last thing you kind of do is distribute that negative. So that negative can be sent to both pieces, so you get negative 2 minus root 3 for your final answer here. All right, and you finally got there. A little bit different looking than the other problems. This simplification with the rationalize the denominator is a big deal. Make sure you practice that. We'll practice it a couple more times in class. All right, and so this last problem is a little unique. It's a little bit different than our other ones, and we'll go ahead and do the work for it. So it says a little bit of information. We need to build a little bit of stuff first, then we can use the identity. It says the sine of this angle A is 3 over 5. The cosine of some angle B is 12 over 13, and angles A and B are in quadrant 1. So let's draw those out, and you absolutely have to draw them out. That's a big piece of this problem, is drawing them out. So we'll start with that first. So we'll draw angle A, and we'll draw an angle in quadrant 1 with the sine being 3, 5. And if you think about that triangle for a second, you know it's a 3, 4, 5 triangle, so we'll label that side 4. And then it says angle B is also in quadrant 1, so we'll draw another triangle in quadrant 1. Whatever quadrant they're in, make sure you pay attention to positives and negatives. It says cosine is 12 over 13, so our adjacent is 12 and our hypotenuse is 13, which means our opposite side is 5 if you do Pythagorean or if you remember your special triangles there. Real quick, I'm going to fix my 13 right here because it's a little hard to read that as a 13. It kind of looks like a B. So yeah, so if you remember your special triangles, for the most part, I'm going to use nice triangles like this that have nice side lengths. Otherwise, these problems get a little messy, a little ugly. The one other thing I do just have to say is if it says A and B are in different quadrants, make sure you pay attention to negatives and stuff that'll happen in these other quadrants. All right, so what it says find the tangent of A plus B. Well, tangent of A plus tangent of B, tangent of A plus B, got a little ahead of myself there, becomes tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. So you're probably thinking, well, why did we do these angles? Why did we draw these angles over here? Well, before we only knew what sine and cosine are, but now that we've drawn these pictures, we can find what tangent A and tangent B are from our pictures. Tangent A, 3 over 4, tangent B, 5 over 12. So let's go ahead and plug that into our problem. So we have 3 over 4 plus 5 over 12 over 1 minus 3 over 4 times 5 over 12. If you want, you can go ahead and multiply this bottom right piece over here real quick. That'll kind of make yourself figure this out a little bit easier in a second. So you have 3 over 4 plus 5 over 12. I do encourage you to do this little mini step right here. It isn't necessary, but it does help. Over 1 minus 15 over 48. All right, so one thing, this is a complex fraction. Hopefully you remember that from Math 3 a little bit. The way you get rid of all these fractions is by multiplying everything by the common denominator. So we got to figure out what we can multiply everything by to get rid of all the denominators at the same time. We have a 4, a 12, and a 48. So luckily 48, if we multiply by 48, it'll get rid of all of those at the same time. So I'm going to multiply everything by 48. So times 48, times 48, times 48, times 48. This is complex fractions. I don't know if you guys remember that. Hopefully you do. So we multiply. So that's a 12. That's a 4. The 48s cancel. And then these ones just multiply. And so now we just multiply that out. And we're almost done. 12 times 3 is 36. 5 times 4 is 20. Over 48 times 1 is 48. Minus 15, the 48s went away, so just minus 15. And hey, look, no more fractions and fractions. That's a nice fast way to simplify there. All right, so you finish this off. 36 plus 20, that's 56 over 48 minus 15. That's going to be 33. And that is our final answer here. So there's a little bit of legwork here. The first thing you need to do is draw your angles, so that way you can find your tangents in a second. Then you do the identity. You plug your stuff in from the triangles you just found, your tangents. You then multiply the bottom right two here together, and then multiply everything by the common denominator. It's usually going to be this bottom right one right here, this 48. So you multiply everything by 48. The 48s cancel here. 48 divided by 12 left you a 4. 48 times 4 left you a 12. 48 times 1 is 48. And then it's just some simple addition, subtraction from there. All right, so these are our sum and difference identities. We have the cosine ones. We talked about that in a previous video. We have our sine sum and difference ones, and we have our tangent sum and difference ones. If you didn't at the time write these all down, I strongly, strongly encourage you, pause the video right now, write these down in a very obvious place, so that way you have something nice and easy to refer to when we're doing our live class session. All right? If you have any questions, please feel free to always reach out. If you don't, I'll see you in our next live session, and until then, I hope you have a great day.